Today's lesson is on the factor theorem. So it says a polynomial f of x has a factor x minus c if and only if f of c equals 0. So all this is saying is that if you don't get a remainder when you are dividing, then you can determine if you have a factor of a polynomial or not. So here we have a polynomial, and we're going to test to see if x minus 1 is a factor and if x plus 3 is a factor. Well, just like everything you know about just basic factors, if it's divisible without a remainder, then it's a factor. So we're going to do synthetic division for both of these and figure out if the remainder is 0 or not. Okay, so setting up the coefficients for the synthetic division, let's first test the factor x minus 1. So bring down the 4. 1 times 4 is 4, and then add 25. Okay, so for this one, we can clearly see we do not get remainder 0, so we have that remainder of 48. So by doing that, we can say that x minus 1 is not a factor of the original polynomial up here. So let's test the other factor, x plus 3. Okay, so bring down the 4, multiply, and add. Okay, so for this one, we get a remainder of 0. Therefore, x plus 3 is a factor of that original polynomial. And then its answer is here. So if this polynomial divided by this is this, we can write that x plus 3 times, let's see, I'm going to write this out, x squared 4, x to the third plus 9x squared minus 2x plus 1. So this times this equals this. Okay, so for this example, we are starting with this polynomial, and I'm giving you one of the factors. So we're going to divide by this factor to kind of break this down, and the goal is to fully factor this polynomial. Okay, so -4, and then I've got 2, -1, -41, -20. And then let's do synthetic division. Okay, so there's my remainder 0, verifying that this is a factor. So now what that means is x plus 4 from here times, let's turn this into a polynomial. That would be 2x squared minus 9x minus 5. So this times this equals that original polynomial. But now can we factor what's left over? Let's see, x plus 4, and then this will factor to 2x and x. That will be a minus 5 plus 1. So by taking one factor and breaking it down, we can keep breaking it down. So now this is the fully factored form of the original polynomial. And then we can clearly find the zeros. X equals -4, x equals -1/2, and x equals 5. So we just found, by knowing one of the factors, we were able to find all of the real zeros of this polynomial. Okay, so here's our last example. So starting with this polynomial, and then I'm giving you this information that 1/3 is one of the x-intercepts of this polynomial. And the goal is to fully factor this and then find the other x-intercepts. So what we're going to start with is, can we turn this 0, this x-intercept, into a factor? That would be that factor 3x minus 1. So I know that I can divide this polynomial by this. Now, for this division, I'm going to do long division instead of synthetic division. All right, so long division, let's divide the first term. So we'll have x squared, and then multiply 3x to the third minus x squared. This will go to 15x squared minus 47x. Divide again. 15x squared divided by 3x is 5x. Multiply. This will go down, it will go to negative 42x and bring down the 14. Divide again, so that's negative 14. And then multiply, so negative 42x plus 14, and we're subtracting, so there's my remainder 0. So now what I have is, so I've got this factor 3x minus 1 times this x squared plus 5x minus 14, and now can we continue to factor? So 3x minus 1, and then x, and that would be plus 7 minus 2. So here's the original polynomial after we knew one of the x-intercepts. That means we know one of the factors. We can break it down, and now we have all 3 factors, and then all of the x-intercepts, positive 1/3, negative 7, and positive 2. So there is your lesson on the factor theorem of polynomials. Good luck.